All right, we're going to look at statistical tables and graphs, how to read data, how to organize the data, how to interpret the data. So let's start with a couple terms. A basic frequency table has two columns. The first column lists all the categories of the data. The second column lists the frequency of each category. Frequency meaning how often does something occur. How many times did we count a particular number, a particular color, a particular variable. The relative frequency of any category is the fraction or percentage of the data value that fits into that category. All right, relative frequency. The cumulative frequency, so let me write this word out, then we'll define it. So cumulative of any category is the number of data values in that category and all preceding categories. So it accumulates numbers. So we start with how many numbers show up in the first category, and then we add to it how many show up in the second category, and proceed from there. All right. The two different types of data that we could encounter are something called qualitative or quantitative. So let me get these written down here, and then we'll go back and describe what qualitative data. And the other one looks a little similar to it. This is quantitative. Okay, qualitative sounds like the word quality. When we talk about qualities of things, we think good, bad, terrible. We think of colors. It's red, it's blue, it's green. Quantitative refers to the word quantity, or how much or how many of an object do we have. So quantitative data would be things that we can represent with numbers, whereas qualitative data are things that we can represent with words. When dealing with quantitative data categories, it's often useful to group or the word bin the data into categories that cover the range of possible values. So you'll hear different categories referred to as a bin of the data. Kind of like think of your cleaning house, and you've got a box where you're going to stick old shoes in, you got a box where you're going to stick books in, you got a box where you're going to stick old clothes in, and you're sorting the data. So each number's got a box or a bin that it goes in, and that's related to the types of categories that we have. So let's take a look at some different types of data that we can encounter and practice identifying whether it's qualitative or quantitative. So let's start with brand names of shoes in a consumer survey. Okay, so what kind of shoes would one think about if you can think of brand names? Keds, Nikes, high tops, stuff like that. Those are all words. So those fit into what we consider to be qualitative data. Okay. Heights of students. So if I ask you how tall are you, you'd say, well, I'm 5'7". You might say I'm 42 inches. I'm 58 inches. You would give me a number. So that's what fits into the quantitative category. So qualitative, quantitative. Audience ratings of a film on a scale of 1 to 5, where 5 means excellent. Okay, we got to be careful about this one. This is sort of a distractor here. When I ask you to rate the film, you're going to give me a number. Does the number have any value as far as the average goes? So if I ask you, what do you think of this film, you would say either excellent, poor, terrible, great. But if I limit you to the number choice, Now you're going to give me a 1, 2, 3, or 4, or 5. So even though I'm giving you, you're giving me a numerical measure, you're not actually giving me a number, you're giving me a number that equated to a word or verbal phrase. So this actually fits back into what's called the qualitative data rather than the quantitative data. Okay, so we're actually going to take a second and look at some data, look at some raw data, and practice sorting it and organizing it, sort of get a sense as to what all these terminologies mean. So we've got 20 grades from a 100-point exam, and we're going to organize this using our different terms about frequency and relative frequency and bins to get a stronger sense as to what the class did on this particular exam. So the first thing we want to do is figure out about how many bins we want. I'm going to look for the highest number, and let's see, looking at it, I think we got about 98 I can see here. And I'm going to look for the lowest number, and let's see, 72, anything beat 72? Okay, so we have 98 to 72 is our highest to lowest. 98 minus 72. So our range would put us at 26. So figure out how many bins we want. Usually, let's see, 1, 2, 3, 4, 5, 6. Usually about 6. Anywhere from 6 to 10 is pretty standard. So we're going to set this up as 6 bins. So if I take the 26, divide that by 6, I get 4 and a little bit. So I'm going to set my bins to be 4 units wide. And I'm just going to start, let's see, let's start with, say, 90, let's go 98, let's just go 99 and 95. And we'll go 95 to 90, sorry, 94 to 90, and then we'll go 89. I'm just going down by 4 each category. And I want to make sure that I don't have any bin that has sort of a double overlap there. So 89 to 85, 84 to 80, 79 to 75, and 74. Try that again, 74 to 70. Okay. So as far as our scores go, so I'm just going to make a little chart here. And we're going to organize our data. Okay, so let's start with frequency. Frequency is how often does something show up. So I'm just literally going to go through and I'm going to put a little tally mark that represents how often something showed up. So 76 would be in this column, 80 would be here, 78 would be there, 76 again, 94 puts it there, 75, 98 up top, 77, 84, 88, 81, 72 is down there, 91 is right there, another 72, 74, 86, 79, 88, 72, and 75. Okay, so what I'm going to do is I'm going to add up my tally marks real quick. This tells me how often something in that category showed up. So I had 1 in that top category, 2, 3, 3, 7, and 4. So then total would be the 20. Okay. And then we're going to look at relative frequency. So how often out of the overall total did we have? So this would be 1 out of 20, which is 5%. So this could be a decimal or it could be a fraction. This is 2 out of 20, which is 10%. 3 out of 20, which is 15. 3 out of 20, which is 15 as well. 7 out of 20, which is 35%. And then 4 out of 20, which is 20%. And then if I add up all the individual fractions, I should get 20 out of 20, which accounts for 100% of our data. Okay. And then the last area we'll look at is the cumulative frequency. Cumulative frequency is just us counting up the numbers as they go. So the first category we have 1, and then I have 2 more in the second category, so I have 3 accounted for total, and then I have 3 plus 3, so I have 6. 6 plus the 3, so 9. 9 plus 7 is 16, and then 20. So by the time I get to the bottom of my chart, I should have every category that's counted. Now I'm going to try to answer the question before it's asked. You just need to pick a direction. I started at the highest to the lowest, just because. You can start from 70 going up and then count it that way. Cumulative frequency is more about keeping track of the numbers as you go down. Okay, so we're going to look at some more vocab here. A bar chart shows each category with a bar whose length corresponds to the frequency or relative frequency. So a bar chart. Let's see, pie charts are used primarily for relative frequencies because the total pie must always represent the total relative frequency of 100%. The size of each wedge is proportional to the relative frequency of the category it represents. Then when we actually look at a chart, we want to consider some important labels. So at the top we have what's called the title or the caption. Let's see, that explains what the graph is about and if appropriate lists where they get the source. Let's see, numbers along the vertical axis, those are called vertical scale. And the categories along the horizontal line are called the horizontal scale. And in the graph, we should have something that indicates the data sets. Those are called the legend. Okay, a histogram is a bar graph for quantitative data categories. The bars have a natural order and the bar widths have a specific meaning. So these would be kind of like what we just did with our number sort. We obviously would put 99 to 95 right next to 94 to 90. I can't rearrange the bars in a different order. Okay, a line chart shows the data value for each category as a dot, and the dots are connected with lines. For each dot, the horizontal position is the center of the bin it represents, and the vertical position is the data value for the bin. A time series graph is a line chart or histogram in which the horizontal axis represents time.